So we are looking at an experiment to understand force on a current carrying conductor in a magnetic field. So we are going to look at conductor and we are going to expose it to a magnet and you guys see what happens. Post that it will be easier to explain the concept. So what happened over there? We used the following apparatus. First, we used a magnet. This end of the magnet happens to be north and this happens to be south. Okay. Then we used a copper wire, right? This is the main thing that we are going to make use of. Battery, right? This is your positive terminal. This is your negative terminal. So the direction of the current happened to be something like this, right? I have something like this, this is the setup I have. Of course, the electrons actually comes from here, but this happens to be the conventional current that we are going to use, is it not? This is the direction of the current, so on and so forth. Then we am using an ammeter. As you guys saw, we are using an ammeter. So now I'll tell you what to exactly observe. Okay, first thing is look at the direction of the current. So one thing is throughout the video, I'm not changing the direction of the current. It happens to be in the same direction, left to right. Then direction of the magnetic field. Well, when it comes to north, the direction of the magnetic field is outward. When it comes to south, the direction of the magnetic field is inward. And the direction in which this copper wire gets pushed. Sometimes it gets pushed towards us and sometimes away from us. Just make an observation. Okay. So these are three things that you need to observe. Now, there's a difference. Okay. To help you guys out, I've done few things. You will see I've edited few things so that it helps you guys to have a better understanding at what you're looking at and more time to get those things. Okay. So your video starts now. Right? Did you guys observe? What did you guys observe? This is the north. So here I have the north. So the magnetic field is coming up. The current is left to right. So it got pushed towards the right, kind of towards its right or towards us. In case two, right, there were two cases. I flipped the magnet, not change the direction of the current. It got pushed that side. So relating these three quantities, which quantity is the push, that is the force, right? Push is a force, is it not? Direction of the current and the magnetic field, relating all this is something called as Fleming's left hand rule. So what does it do? It relates the magnetic field, the current, and then the push. So where can we apply this? Think about it. It's not too hard. So people who want to make a running note, you can do so now.